All right, good morning and welcome back. Today, to start off, is just a little bit of a review, the same thing we did on Monday. So, right here it says, what is 0 less than or equal to theta less than 2 pi? What I mean by what is this is what's our label. So, this is going to be in radians. If it was degrees instead of 2 pi, that would be a 360 degrees, which we don't have. So, radians, we know this is going to be radians for the whole day. That's what we're dealing with, because right here you see it tells us from 0 to 2 pi, including 0, not including 2 pi. So these first three questions, hopefully pretty easy. Cosine of theta equals 1/2. We just say, when does theta equal 1/2? So we think cosine is the x value, so we look at our unit circle. When is the x value 1/2? It's going to be right here at pi over 3, and then also right here at 5 pi over 3. Okay, that is when x is 1/2. So pi over 3 and 5 pi over 3. Just so you know, on today's Delta Math, they don't have a pi button there. You can access it by clicking on the keyboard, or the other option is just type in pi, and it will turn into the pi symbol for you. Okay, your next one, tangent of theta equals square root of 3 over 3. I'm not going to show you guys, but just find where is tangent square root of 3 over 3. That occurs at pi over 6 and at 7 pi over 6. And our final one, where is sine of theta equal to -1? So where is the y value equal to -1? That only actually occurs at one spot, at 3 pi over 2. Remember, when sine is -1 or 1, when cosine is -1 or 1, those are the two spots where you only have one answer. Okay, so this next section now. There's kind of three different things we're learning today. This first section is just, what if sine's not by itself? So we need to first isolate sine, and then we can solve it just like we did on the first one. So to isolate sine, we could divide by 2. Divide by 2. Sine of theta will then equal negative square root of 3 over 2. Okay, negative square root of 3 over 2. If we look on our map, or our unit circle, then theta equals 4 pi over 3 and 5 pi over 3. All right. Example 5, to do this, start by subtracting 1. If we subtract 1 here, we'll be left with negative cosine theta equals, let's think about this, 3/2 minus 1. 1, I could rewrite that as 1 over 1. Okay, now I need to find a common denominator. So I will take 2 over 2, which is still subtracting 1. 3/2 minus 2/2 leaves us with 1/2. At this point, we got to divide by a -1. Divide by a -1, we're left with cosine of theta equals -1/2. Okay. So now we go on to our unit circle. Where is theta equal to -1/2? Where's the x value, equal to -1/2? And that's when theta is 2 pi over 3 and 4 pi over 3. Okay, so that's kind of the first new thing we talked about today. If it's not isolated, you need to isolate it before you can solve. Okay, the second thing, I hope you can notice right away on 6 and 7, it's cosine squared or tangent squared. Okay, what do we do if it's squared? First step is still the same. We need to isolate it first. So let's divide by 4. Divide by 4, we'll be left with cosine squared theta equals 2 over 4 is 1/2. Okay. Now at this point, to get cosine squared to just be cosine, we have to take the square root. If I do that to one side, got to do it to the other. Now, let's talk about this. X equals the square root of 4. If that was the case, then we know x equals 2, because the square root of 4 is 2. Now, if I have x squared equals 4, to solve this, I would take the square root of both sides, and this is where it's a little interesting. X in this case would equal plus or minus 2. If we add the square root in, then it can be plus or minus. If the square root's already there, we're just going to take the positive, take it to be positive. But if we add that square root, we put the plus or minus. So in our case here, this is plus or minus. Now when it's a fraction under square root, we can split it up. So square root of 1 over the square root of 2. So this leaves us with cosine of theta equals plus or minus the square root of 1 is 1, and then the square root of 2 there. Now hopefully you notice we cannot leave that square root on the bottom, so we need to rationalize the denominator. And that leaves us with plus or minus square root of 2 over 2. Now, at this point we are ready to go, but notice there's a difference here. Now it's plus or minus square root of 2 over 2. So because of that, there will be two answers for the positive square root of 2 over 2. There will also be two answers for the negative square root of 2 over 2. Okay? And so because of that, we will have 4 total answers. So we want to find where is cosine either positive or negative square root of 2 over 2. So that will occur at pi over 4, at 3 pi over 4, at 5 pi over 4, and finally at 7 pi over 4. All right. And hopefully you notice when you look at that, all the denominators are the same. As we look back through our examples, you'll see when we solve these, the denominators match up. So that's kind of a clue for you. If that doesn't happen, something's up. Okay, number 7. Once again, subtract 5, we're left with 3 tangent squared theta equals 1. Divide by 3, tangent squared theta equals 1/3. At this point, we're taking the square root of both sides. It's going to be plus or minus square root of 1 over square root of 3. Okay, and at this point, so we get tangent of theta equals plus or minus, it's going to be 1 over the square root of 3. We can't have the square root on the bottom, so let's rationalize our denominator. Plus or minus square root of 3 over 3. So now we're saying when is tangent of theta equal to either positive or negative square root of 3 over 3. And this will occur 4 times at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right. And that is all for that one. So one last thing I want to talk about. This final thing is number 8 and 9. Ask us, what do we do if we have either cosecant, secant, or cotangent? So once again, we always start by isolating whatever the trig function is. So let's add 2 to both sides. We'll have cosecant of x equals 2. At this point, we can rewrite cosecant. That's not in our unit circle, so we need to rewrite it in terms of either sine, cosine, or tangent. So cosecant of x is going to be 1 over sine of x. Also, I forgot to mention, I used x here. I used theta on the front side. It's just a variable. It could be y, it could be z, it could be b, it could be a squiggle. It's just a variable. Okay, so 1 over the sine of x equals 2. Now, we know technically 2 is over 1. We could cross multiply here. We'd get 1 equals 2 times sine x. Then we divide by 2. We get sine x equals 2. The other way to think about it is simply take the reciprocal of both sides. As long as we do it to both sides, it's still equal. So we get sine of x equals the reciprocal of 2 over 1 is 1/2. And now we just want to know where is the sine equal to 1/2. So where's the y value equal to 1/2? And that is when we are at pi over 6 or when we're at 5 pi over 6. All right. One last problem today. Number 9, start by isolating secant. So divide by square root of 3. Divide by square root of 3. The secant x equals 2 divided by square root of 3. Now some of you might be thinking there's a problem there because we got a square root on the bottom. And I agree with that, but we aren't done yet, so we don't need to deal with that because eventually we're going to take the reciprocal. It'll sort itself out. Okay, so secant is 1 over cosine x. Some of you can probably skip this step, just jump right to the reciprocals. but I'm going to write it. So cosine x equals, do you see we take the reciprocal here then, square root of 3 over 2. And now we just find where is the x value square root of 3 over 2, and that occurs at pi over 6 and at 11 pi over 6. Hope you guys had a great day. Make sure to sign into Delta Math and get that done. Quarter's coming to an end quick, so if you have any missing work, please let me know. Hope you guys have a great day.